Hi, 6th graders. This is Mrs. Gall. Today we're going to go over adding and subtracting fractions. Open up your notebook to a fresh page and put this title at the top. When you're ready, press play. We're going to start with a real-world example to help connect the process of adding and subtracting fractions. So we have Katie who's making smoothies. The recipe calls for a 1/4 cup of strawberries and 5/8 cup of blueberries. How many cups of berries are in the smoothie? Let's look at a visual to help us decide how many cups of berries are going into the smoothies. So we have 1/4 and 5/8 cups of different types of berries. If we look at a visual of 1/4, we see the yellow one piece shaded in for the 4 total parts. If we think about 5/8, we have 5 yellow shaded in out of the 8 total parts. If we think about putting those two pieces together, it's really easy to visualize here that 1/4 fitting in for 2 of those 8s. You can see that picture. If we fill in a 1/4, it takes up 2 of those 8s, and then we can fill in our 5/8 there as well. How many total cups of berries is that? Well, it looks like we have 7 of our 8 pieces shaded in, so that would be 7/8 cups of berries. Why are common denominators needed when adding and subtracting fractions? So you'll notice we took our 1/4 and we actually kind of had to think about what it was as 8ths before we could add in those 5 other 8ths there. Common denominators are important because when we're adding and subtracting wholes, we want to make sure, or parts of our wholes, we want to make sure that we're adding and subtracting pieces that are the same size. That's why it's important to make sure we have common denominators. Let's go into looking at some numerical examples. Please make sure you're writing these down with me. Press pause if you need more time. 3/5 plus 1/3. The first thing we want to do is find a common denominator for these two fractions. So we want to ask ourselves, what can 1/3 and 5ths both become? You can always multiply them by each other. Sometimes there are other multiples that they would match up at. It's kind of like finding the least common multiple. For 5 and 3, the first multiple they're both going to meet up at is 15, which is just like multiplying them by each other. Whatever we're multiplying the denominators by, we also want to multiply the numerators by the same thing. For example, in order to get 5 up to a 15, I need to multiply it by 3. So that means I also need to multiply the numerator by 3 to make sure this fraction stays equivalent or the same value. This fraction now becomes 9/15. Same thing for my 1/3. I know I need to get the common denominator, which is 15. And so to get my thirds up to 15ths, I'm going to multiply by 5. To keep the fraction equivalent, I need to make sure I multiply the numerator by 5 as well. My new fraction is 5/15. When I go to add or subtract, I focus on the numerators. We have a 9 plus a 15, or plus a 5. 9 plus 5 gives us 14. Now the denominators, we are not changing the number of pieces in these wholes. It's going to stay the same. 15 is going to remain the total number of pieces. We do not change the denominator. 9/15 plus 5/15 gives us 14/15. Before we determine if we're finished, we want to make sure that our fraction is written in simplest form. 14 and 15 do not share any other factors besides 1, so we know we are in simplest form, and this is our final answer. Let's look at another example. 1/6 plus 3/4. We need to start by finding common denominator for 6 and 4. Is there a multiple you can think of that 6 and 4 could meet up at? Maybe you said 24 because you could multiply them by each other. but there is a smaller multiple that they meet up at. It would be 12. How would I get my 6 to turn into 12ths? I would multiply by 2. So that means I want to multiply both of the pieces in that fraction by 2 to get to 12ths. How would I get fourths up to 12ths? Multiply by 3. That means I want to multiply both of the pieces in that fraction by 3 to get that fraction up to 9/12. Now, if you chose 24ths, that's great. You can use 24ths. You'll just have a little bit more simplifying to do at the end of the problem. We start by looking at our numerators. 2/12 plus 9/12. 2 plus 9, we add our numerators to get 11. Our denominator does not change. It stays 12ths. We ask ourselves if 11/12 is in simplest form. It is. So our final answer is 11/12. If you would have picked 24ths, you would have ended up with 4/24 and 18/24. And when you would have added your numerators together, you would have gotten 22/24. This is not simplest form because both of your values are even. So from here, you would have wanted to divide both of these numbers by 2 to get down to simplest form. And that would have given us 11/12, just like we got when we chose 12ths right away. So that's two different pathways to get to the correct answer. Let's switch gears and go into subtraction, which is very similar. We're now just going to subtract our numerators instead of add. So we're looking at 7/8 and 3/4. Oops. Oh, that did not like me there. Let's restart that. 7/8 and 3/4. We continue to ask ourselves, what's a common denominator that both 8 and 4 could become? So what's a multiple they both share? There's actually a couple of options here. My least common multiple for 8 and 4 would actually be 8, but you could also use 16, 24, and other numbers, or 32. So if I wanted to use 8, which I would highly recommend, your first fraction is not going to change. It's going to stay the same. How am I going to turn fourths into eighths? I multiply by 2. So if you ever have a denominator that can turn into the other denominator, I usually recommend that route because it's just going to be the least amount of work on you. So the second fraction turns into 6/8. The first fraction gets to stay the same. We now focus on the numerators. 7 minus 6 gives us 1. Again, the denominators do not change. We are not changing the total number of pieces here. It stays 8. 7/8 minus 6/8 gives us 1/8. Again, you could have chosen a different denominator. If you did choose a different denominator, you would have wanted to make sure that your answer is in simplest form before finishing the problem. All right, you guys, one more problem we're going to try together. 3/4 minus 5/9. If you're feeling good about this process, go ahead and pause and try this one on your own and then press play when you're ready to see the answer. If you want to stay and walk through this one with me, feel free to do that as well. We want to start by finding a common denominator for 4 and 9. I think the best we can do here is just multiply them by each other. There's not a multiple besides 36 or before 36 that these two numbers share. Remember to multiply your numerators by the same value you're multiplying the denominator by, and you should end up with 27/36 minus 20/36. 27 minus 20 gives us 7. 36 should stay the same. 7 is prime, and 36 cannot be divided by 7, so that means we are in simplest form. All right, you guys, that's all I have for you for adding and subtracting fractions today. Check in with your teacher if you have any other questions.